Alright, so here we have the Geprc Quadcopter, and these are all the components I'm going to use. Now, as you can see here, I did a little modification to this. I put some, I'm not going to say Plasti Dip, but that's the popular brand. I used something called Flexi Dip, which is half the price. But I used it for the whole entire quadcopter, and then I actually used some clear coat polyurethane. Very shiny. And this stuff can be removed, by the way, but with the clear coating that I have on it, it is a little bit harder. Okay, so let's just go over some of the parts. Now, for this Quadcopter Build, which is a 5-inch, this is a 220 frame, 220 millimeter, so you're not going to be able to swing 6-inch propellers here. There's 2 sets of these, okay, and I wasn't quite sure, but the only thing I could come up with when I see the difference here is that 2 of them, and this go from the inside, so this would be on the inside, this would be on the inside. You can see where the screw goes here, where the screw hole is routed in. But anyways, I have 2 of them. One have these and one don't, so I'm not sure what is which. But even if I have to remove this to put the camera on again, then so be it. But there's, you know, two sets for 2 types. This sits on top of the flight controller. The VTX is supposed to sit on that, but we'll see if I use it or not. Now for a controller transmitter, I'm going to stick to my Spectrum. Still with the older style. I didn't want to use my new Spectrum receiver. I want to use that for the 6-inch Martian build. Flight controller, this is what I'm going to use. Right here. CL Racing F4. We have a battery mount for underneath. Sometimes I don't really use these battery protectors. So we got some bobbins here for vibration dampening. And we got the extra hardware here. Okay, we'll move on to the ESCs, and these are D-Shot DYS 30 amp. XSD 30 amp version 2, so you can do up to, I think you can do up to, well, I know for sure you can do D-Shot 600. Any more than that, I'm not too sure, I apologize. These are the motors I'm going to be using, the Emax 2206 2400 kV. Okay, now for a transmitter, I haven't decided. I have this FX 796T. I also have this Amway. Obviously I'm not going to be using this antenna. And then I have my Runcam Swift 2, which looks awesome. It's got a 2.1 millimeter lens. This is your traditional HS 1177 mount. They give me an extra case for it, which is cool, and that should be able to fit in there quite nicely. You got a battery strap here, it goes right underneath. You can see all the crud and rubber in there, and this is for if I want to use some kind of a video camera on top, but I'm not. And they give you some zip ties too. And I'll be using this antenna here, pagoda antenna here. But this should look quite nice. It says designed by Martin with 2 A's, Bert. Here's a little quick Geprc quadcopter unboxing. And they do provide a power distribution board for you if you want to use it. Another reason why I wanted to use Flexi Dip is because I don't like the color gold. Just FYI. Okay, it looks like we have everything out of the bags. Everything's was nicely packaged, so that was good to see. Now, just right off the bat, the arms look really good in that they're especially because they're beveled here or sanded off, so you don't have to worry about prepping the frame in the traditional sense where you're, you know, sanding or making things smooth yourself. That's already done here for you. This quadcopter build is fairly simple to put together. They give you a diagram to follow, so it's pretty straightforward. Putting in the 10mm screws with some blue thread locker, and then I'll move to the inner 4 screws where the stack mounts. This is the top, the front I mean. Okay, these are the 12mm screws. These are the 10. So what I did is I put these on first, this one Loctite, and then I tried to put these through, and it was a little bit difficult in some places where, well, in 3 of them, so I had to actually screw them in. So maybe what I suggest is put these in first, then install these. Now these aluminum supports go a certain way, as you can see that goes on the outside for both. But if you only wanted to put one and then put the flight controller, it's totally your choice. You just have to be cognizant of the space that you have. This thing is, I need to get a screwdriver. Right one. Okay, can you take me seriously? Okay, I'm not going to put it on too tight. I'm going to put the second one on. Oh, a little bit too much here. And I believe there's 2 types of polyurethane, oil-based and water-based. You want to go with, I don't know, I'm just using this. I can't make a representation on that. I don't know too much about this stuff. All I know is that it's a spray-on plastic, right? Polyurethane, isn't it? So yeah, so vibration dampening was my main thing. And visibility was another thing. So hey, I got red. And we'll see how it works when the motors are on. So for you Spectrum fellas, gals too, what I did is, instead of using the gold screws that came, the 4 gold screws, and I believe they are 10mm, okay, I went, this is it right here, because this is plastic, but I chose a metal one. I went with the 14. So you're going to need a 14mm substitution for the 4 screws that go underneath here. Okay. The reason why I chose to use the taller screws was so that I can fit the satellite remote receiver inside or underneath the tower without any issue, and fastened with some Velcro, and which allowed me to use the vibration dampening bobbins and also the nylon nuts. I had the motor on for a day, and I took it off so that I can use some blue thread locker, and I noticed that there was an impression, I don't know if you can see it there around the screws, that the actual motor compressed into the flexi dip. Okay, now we're going to move on to the CL Racing F4 flight controller. You'll see the EAC pads are opposite to each other. And you got a signal pad in the middle. There's no ground signal on this flight controller, but I suggest using the signal ground and just attaching that to your power EAC ground. Now moving on to the Fpv camera, you'll see the 3 pads right towards the top underneath the ESC pads, starting with the signal, and then there's the positive in the middle and negative. The VTX follows the same format. Signal positive, negative, and if you're using an immersion RC tramp or TBS Unify, the sound wire, I know I'm pointing to the RX4, but it's actually TX4, so my mistake, my apologies. Also see the main battery leads. There's the OSD chip, get an SD card reader, and on the top is your RC control, whatever protocol you're using. So S-Bus, I-Bus, satellite, which is your spectrum, and also PPM. There's also a telemetry pad for S-Bus users, so that you can get your telemetry through your receiver. And you'll need the 5-volt for that in the ground, so very straightforward. Okay, flipping the flight controller one more time towards the top, you'll see that there is a boot button on the top right next to the USB. You have your gyro, an accelerometer, and your buzzer or beeper that only works on Betaflight 3.2. And lastly, you have your LED pads should you decide to use them. Now this is the wiring diagram for the CL Racing F4 flight controller version 1, and shows the S-Bus, PPM, I-Bus, and SAT connection. SAT is just for your spectrum and DSMX. And on the opposite side, you can see where all the ESCs and the signal wires solder up. Pay special attention to the Immersion RC and TBS Unify, in that the audio wire to utilize the smart audio function goes on TX4, so that's transmit UART4 connection. Now some of the specifications of the CL Racing flight controller are, obviously it has an F4 chip, it has MPU 6000 gyro and accelerometer, also has an SD card slot, has a built-in 5-volt BEC, a built-in 7.6 volt BEC, and it's filtered for either your camera or VTX. Obviously it has the built-in Betaflight OSD, current sensor, and PDB. It has 3 UARTs plus the USB. It also has a 5-volt LED strip output. It has a dedicated S-Bus hardware inverter. It supports TP and smart audio for your VTX. Obviously it's D-Shot ready. And it supports all the Betaflight features. Now for the flashing and setting up of the flight controller, I'm going to refer you to Joshua Bardwell's YouTube channel. He's pretty much the go-to guy for that sort of stuff. And I'm just tinning the main LiPo battery leads for the flight controller. Ooh. It's important to keep this very still. This is 60/40 solder. It does have a window of cooling. That's why you want to make sure. And you feel that heat through the wire. So let's leave it. It doesn't move. I need some helping hands. I want to see if you get any shorts, man. Because if this thing lights up, we have a problem. I think it's going to light up for some reason. No? Actually worked. I snipped some 14 gauge wire as a substitute for this 18 gauge wire that's existing on the DYS 30 amp ESC. I want to use something a little more with more capacity. Certainly your choice, you don't have to, but I'm going to solder everything onto the flight controller first. I'm also going to solder on the camera lead, okay, which go right here. I'm using this FX796T VTX video transmitter, 200 milliwatt. I think it's switchable to 25. Now this is the connector it provides. Now you can remove the black and the red since you don't need it. You're going to be powering it through the flight controller. So you can remove this, just save it for a special day. Go for something else. And all you're left with is this. which goes into the VTX this way. All you gotta do is decide how much wire you want. You know what, I just want to play it safe, so I'm gonna cut this here. The camera, same thing, but not too much, because then you have too much of a wire management issue. So this needs to be soldered on here. I'm not going to use an LED strip, which will go on the last three here, but you certainly can. Okay, so now I'm going to be desoldering the wires from the ESC so that I can use the thicker gauge wire for the power wires, and for the signal and signal ground I'll still be using those. I still need to remove them. And now we're going to quickly tin the flight controller. Put some flux on there, rosin core flux, just to help the solder flow. Please no light, please no light, please no light. There you go. Okay, now I'm going to be soldering the Fpv camera and video transmitter wire leads to the flight controller. And finally, I'm going to solder my Spectrum wires for the remote satellite receiver. Alright, I'm done. But I'm not. Okay, we have the Spectrum connector here. We have the VTX. Just be careful when you do that, and then we have the camera, which is going to go to the run cam. So that's basically it. And then you can have your LED strip, if you wanted to, over here, these three. Alright, so I removed all the power signal pins from the ESC, and I tinned the pads, so they're just ready to be fitted, and just want for the wires to be soldered on. And now what I have here is the 4 signal wires, and I'm going to tin these up. Okay, so I've soldered on the signal and ground wire to the flight controller, so that pretty much does it for the soldering of the flight controller. The next step is to mount this into the actual frame of the quadcopter. But I'm going to check it one last time with my smoke stopper just to ensure there's no shorts, and then we're good to proceed. Looks like we're all good there. Okay, so I stuffed that, I had to stuff that in very carefully, and I had to use some tweezers just to kind of push the wires out. And be very careful, because you don't want to bulldog it through. You might damage the flight controller. Anyways, I got it in here. Now all I need to do is just place the ECs where I want them. So probably just flat up against here. And then I'm going to take the VTX. Yeah, the VTX is this one. The FX7960 with a lava solder on there. Can't get off. But I don't like, I'm going to have a tough fit with this, and the antenna mount is here, and really what I want to do is just remove this SMA and solder the antenna directly to it. I find that I get way better heat dissipation, which just translates into better antenna propagation. You have less points of resistance too. And when you're dealing with brass and couplers and connections, every point of every connection you're losing propagation, you're losing antenna. It's just not going to look as good. It'll get hotter faster, etc., etc. But this thing is looking pretty good. It's not light, I can tell you that. It's heavy. This is the heavy quadcopter. So what I went ahead and done is trimmed all the wires, which had to be individually sized so that I get, you know, a good length, so I don't have any crimps, or, you know, so it fits nice. And I had to do that for all four. So I have to tin the power wires and also the signal and ground wire for each arm, for each motor, for each ESC. Alright, so I have all the ESCs from the DC power all connected, and I only have the motor wires left to solder onto the ESCs. I'm not going to be using these things, I'm sorry, they're just a little bit too cumbersome for me. Now I've soldered on the power, the signal, and the ground to the signal. What I'm going to do now is I'm going to clean these up, these connections here, and even some in here. Just clean this all up with some rubbing alcohol. Try and use the highest concentration as possible. Please don't use 70% unless you want to wait till the next day. Alright, so now that I have the ESCs all nice and clean, I'll put some clear heat shrink, the heat shrink that came with the ESCs. I don't know if I showed you this is a new Spectrum. Receiver. Awesome. Diversity. As you can see, now you have the extra coaxial cable, so you don't have to worry about the carbon fiber blocking out your signal, and fail-safe in it. That tends to be the case. Now, whether you're using the old or new Spectrum satellite receivers, the point is that if you want it to fit the way I have it, you need to use the 14mm screws along with the nylon nuts and the vibration dampening bobbins. So you hit this type, and the O-rings. Then you place some nylon, I think they're 4mm, on the top, and then you just put the VTX plate on top of that. So last step in soldering is to solder the motors to the ESCs. As you can see, I'm using a different type of solder here. This is 6337, which has more tin, and it's only rolled up because the diameter of the solder I had was only 0.3mm, so I had to make it thicker. So we're just going to solder the ESCs to the motor, and that's probably the last and final step. And we'll check it again here with the smoke stopper for each connection, just to ensure that there are no shorts, and if there are, we can easily trace it back in a consecutive and logical way. Now, we should borrow the current limiter, aka smoke stopper. Try it one last time here, see if we're doing everything okay. We're good. So by putting this here, you're giving it some stress relief. So if the battery ejects, it's not going to rip out your, or damage your flight controller. So now I'm just mounting the antenna. Believe it or not, this is Spectrum. So 2 zip ties on each end, on the arm. So they're going to be like this. And as tight as I possibly can, right? So they're not going to go anywhere. What I need to do is find some heat shrink that would go over that. So I went ahead and used the original case that it came with. As you can see, it has those 2 extra hooks. Not hooks, 2 extra holes, and the ones in the center. Now, I'm a little bit peeved at the whole thing because they had a case in here. It would have been an awesome case to fit in here, for the reason that this lens here was sunken in more and it had better protection. Now, with this new setup, we got a lens that's exposed here. So now I just have to decide what to do with this, if I'm going to desolder the pin and solder my antenna directly, but I may just do the conventional way and add a piggy tail and go through here. I mean, it's going to be a small one unless I can get this transmitter through here, but this will snap it right off too. Well, I'll have to figure something out for this. So this is a 3-position switch, in the middle is arm, and then the last one's failsafe with the beeper, and this is your mode. So if I want my gyro on, I just flick this on. Okay. There we go. Right, as you can see, I have the, I don't know if you can, I have the Emax Avant props. These are the bi-blades. Okay, now I'm just going to give a quick test with some Dell Prop trapezoid series. They're the 5044. Alright, we're going to make a few modifications. There's only two things I want to do. I put on this protector here. It's broken, but I can just put it on here. You can see this crack. Because this thing protrudes a bit, right? And some people have complained that they've had this camera broken, this type of camera, and this frame. Keep in mind, this is a 2.1mm lens, so there is a possibility that I may get some scope of view kind of limited. Alright, like you may see this on the peripheral. If that's the case, I'm getting rid of this, but and just I'll use an elastic on it. So when you talk about noise, it could be audio as well, and I'm thinking that a capacitor on all 4 ESCs, and guys, it doesn't mean you can't use recycled capacitors. Just test them out, and they should be within 20% of what they're rated for in terms of capacitance. This is 25 volt. This is a 4S setup, so this is the lowest I'd go though. It's 25 volt, and they're on this Simon K. They haven't done much because I haven't used these ever. So I got 4 of them sitting around. I'm going to be using these. Okay, so putting these on, you just have to follow polarity. All right, and it's very easy. The negative is on here. You can see it, right? Negative, positive. I'm going to desolder that from these Simon K ESCs. And this one says, and you want low ESR. If length's an issue, you just put some wire. Just some wire and attach it. Excuse me. So in my situation, let me see. I'm just thinking. I'm just measuring. Yeah, it'd be kind of tight, but you know what? It should be okay. So guys, for polarized lenses, $390. Let's see without a battery strap. So now I got 4 1000 nanofarad low ESR capacitors. Did I try the last one or what? I don't think I did. Oh! See that? See that? See? Look at this. You got a problem. Which one did I do last? Yeah, so the last one I did caused a short. So I'm going to try and put it back. It seemed okay, but I don't know, maybe the combination of all of them? Like, I have no idea. Or did I use the wrong polarity? Ooh. Could have used the wrong polarity? Maybe not. Just going to make sure I get it right this time. And this one goes. Okay. Again. So one last time here with all of them on. Please don't light up. Oh yeah. It's all good now. Just trying these, and I put a what do you call it there? A ferret ring before the VTX. So this thing should be in tip-top shape. I don't know. It's kind of nerdy looking, but hopefully it's really functional. Hopefully this will fix the audio issue that I have. And yeah, that's the hope. Alright, we're out here. We're going to test this puppy out. We're going to test this Geprc with the capacitors on, see if there's any difference with the microphone. I'm going to start off with this R-line tattooed 95C 1550. I'm going to take the lens off here. Now this is a 2.1 millimeter lens. I did want the 2.5, excuse me, but they were all sold out, so it's not too warm out. It's about what? What would you say? 5 degrees? Something like that. But I just want to see if there's going to be a big difference in the audio. I'm not sure if the capacitors make it any better. This is where we are, right? So the wetness. It is kind of fast, though. Hotel. I hit a tree, and this is the Geprc build, and as you can see here, the right arm is totally busted off. I wouldn't expect this kind of damage from hitting a tree, but who knows how it hit? You know, it can happen. Now you can see that there's like 2 layers in here. So it doesn't seem like it's a solid piece of carbon fiber, but everything else survived.